This one's really for Peter, just a toast to his memory, to his contribution. If you've ever used DataGuard, then you have him to thank. He's a big part of that, was a big part of that DataGuard team. We'll miss him, and he was a fantastic element of the Oracle community. Good evening, everyone. Hopefully you can hear me. Hopefully you can see me. Just bear with me a little bit of just let's get my audio and video in sync. There we go. Also scares the daylights out of my dog, but not to worry. Welcome, everyone. It is office hours again. Let me bring up the chat window just to make sure that if anyone can't hear me, they can see me, etc. Good. All clear so far. Welcome again to July's office hours. Thankfully, I think the Olympics has not started fully yet, therefore there are no distractions to take you away from hopefully some good fun tech content today. Welcome as always, and let's jump straight into the slides. We'll get through our bits and pieces and hopefully we'll have a good fun interesting hour. Let me share my slides. The sound is very low. Oh, hold on, I know how to fix that. Bear with me. I was doing some playing with my sound the other day. Hold on a second. Okay, move a bit closer. Hopefully that's a little bit better. Seeing out if it's not better. Is that a bit better, everyone? Yes? Someone on the chat say yes, no? I hope so. If you can't hear me, turn it up. Yeah, I've been tinkering with some new microphone technology, some stuff, but obviously I've changed my settings a bit low. But not to worry. Let me share my screen so we don't burn too much time. Okay. As always, I love talking technology. Getting in touch with me is very, very easy. Rather than a million links, just go to linktree/Connor. Probably the easiest way is the Connor MCD at Twitter. That's probably where I hang out most of the time, as I see a lot of familiar names on the attendee list, and obviously those people generally hang out on Twitter as well. So that's the easiest way to hook up with me if you want to get in touch, and then we can go from there. But if you like things like Instagram, Facebook, LinkedIn, blogs, etc., then there's lots of options there out on Linktree. And of course, QR code now for those modern, new, cool people in there who want to keep up with stuff. As I always say, do not adjust your set. We put all the content down at the left-hand corner of the screen, such that when we turn this into a video for YouTube, it has a nice balance with the content down at the left, the quality content down the left, and the low-quality presenter at the top right. As always, I like to start with some bits and pieces. And you may have noticed if you joined a little bit earlier, I normally have, for lack of a better term, some hold music playing before everyone jumps on and joins the conference. You may have noticed that normally it's fairly relaxed and obtuse to sort of ease us in. This week I had it much more upbeat, much more uplifting. And there's a reason for that. And that is for the Oracle community. It's been a really sad time we lost Joel Kalman a couple of months ago, and just a week or two ago we lost a real champion of the Oracle community. Only recently joined Oracle, Peter, but most of us would know, for anyone that's been to a conference anywhere in Europe or open world, etc., would know Peter really well. Just a fabulous, really young guy. Unbelievable that he's gone, and I think it just shows that, you know, as a community, we so much have to strive to look after each other and be there for each other. You know, we're not just tech friends, and this is a real tragedy. He always used to say that, you know, we would one of his goals was to join Oracle and become a product manager, which he did a year ago. But yeah, it's just a tragedy to see him gone. Such a, you know, everyone on Twitter that was mourning his passing this week was just saying that, you know, the thing that always stood out was just his spark. And he always had that, you know, you can even see from the picture, he always had that little glint in his eye, that sparkle of excitement when it came to talking tech. So this is just a real tragedy. So that's why I played the upbeat music, just to try to lift my spirits a bit and hopefully lift yours a bit, because it's just been a terrible, terrible time recently for Oracle people. So I'll try to keep things upbeat. I won't get too maudlin, but yeah, just a sad time. pushing my local region here. If you're here from anywhere in the Asian time zones or APAC time zones, we have our normal Ausdruck user group webinar series continuing on. Please, there's been some great ones by Carsten of late. So people from all over the world are speaking at this. So hopefully you can all attend those ones. The podcast is live. The reason I'm spruiking the podcast is I've just released a fresh episode, bit of a controversial one. SQL tuning is generally not what you want to be doing. And I present just a different take on the challenges that many of us face when we're doing SQL tuning. And the other reason I wanted to mention podcasts is if you're a fan of podcasts, I've been participating in one of the other Oracle podcasts that has been going for a long, long time, Digital Impact Radio. That's a guy named Franco Ucci, who's also based in Australia, but he does a lot of these podcasts, a little bit shorter format than mine, but just like sort of good, more of an interaction kind of chat. He hosts it and I had a chat with him just recently. That podcast will be coming out shortly. I've done a couple in the past as well. So if you ever want to check out all the Oracle podcasts, just go to podcasts.oracle.com. But obviously, I give preference to mine. The spoken nerd is how you get to my podcast. Last month, I put this slide up, and the emphasis here was revealing that there was not going to be a 22C release, and that's why you can see the blue arrow. The blue arrow there talking about there would not be a 22C release. So I wanted to cover that thing off. But now that it's July, I want to shift the arrow a little bit. And the reason I want to shift the arrow is there's something just as equally important to talk about, and that is 18C. If you've been running 18C, its support expired at the end of June or thereabouts. It's either now or on the cusp. It's about to end support. And probably the easiest way of if stressing the importance of being on those right supported releases is this. July's CPU came out. There's critical patch update that's got security updates. Luckily, the database fared fairly well. Very few security updates required there. If you're running Fusion apps, there's some more critical ones. It's always the middle tiers that generally get the greatest level of exposure here because they're obviously the outward facing parts of your application, but the database still has a few things that need to be patched. And so as always, I recommend you patch to the latest patch levels. But the key thing is if you read that patch note, and there's the link down the bottom there, hopefully if you're a customer, you would have gotten the email anyway. If you go on that link and follow the trail to the Moz notes, you'll see this. And this is the critical thing I wanted to stress. We've got security patches for database 19, security patches there. That'll take you, I think, to 19.12. We've got security patches for database 12.2, and we've got security patches for database 12.1. What's missing? No 18C. 18C is out of support. We don't do ongoing patches for unsupported releases. So please follow that. If we flick back to the thing again, remember that concept of innovation releases versus long-term support releases. The place you really want to be, if you're probably 99% of all Oracle customers, is 19C. That's the one that's going to be supported for a long, long time. So just to reiterate, that a particular key moment has passed, namely the end of June, July. 18C is no longer going to get active patches. So security, I swear, I follow a guy named Troy Hunt on Twitter who runs the Have I Been Pwned site. And I swear every day, like there's a new breach. So security, put everything else aside. Please patch your databases to stay secure. I will say, just an addendum there is because we are so focused on security, we are trying to get these patches out as fast as possible. We put the note out and we put the first round of patches out, but other platforms and other environments will catch up over time. We didn't want to sort of wait till everything was ready for all the different platforms and all different versions to say, yes, here's your CPU. So literally, if you go to those patch notes, you'll see some of the patches, you'll click on them, it'll say patch not yet available. But the moment we had some available, we wanted to push them out such that those on those more common platforms, the Linuxes of the world, etc., are going to be able to get those patches on as soon as possible. So please be patient. If you click on a patch for your particular platform, particular version, and it's not there, just try again tomorrow or the next day, and we'll push them out as literally as fast as we can. As I always say, these office hours are driven by questions that come in from you, the community, but If you have particular topics that are relevant to your particular customers, your particular office, your particular IT department, please feel free to reach out on database topics, and we should be able to put office hours sessions together that are dedicated to the topics that you need for your particular site or particular customer base. As always, and as I always hear, personal bias, I am desperate to go traveling again. I'd love to go traveling again. I actually spent 2 weeks in isolation recently. I went traveling to Northern Territory and got stuck in a COVID lockdown. Northern Territory had never had a COVID outbreak until I went there for the weekend. So I had 2 weeks of isolation here at home to make sure I wasn't COVID positive. But yeah, please get vaccinated. Let's get our communities back together. Let's get some in-person events going again, such that we can come out of this. So what time is it? Oh God, meandering as always. We got a lot on the plate tonight, but a lot of these are fairly short. So we might get through all of them tonight, hopefully. That we're going to talk about partitioning with time zones, an interesting discovery regarding %free, one of those fundamental building blocks that's always been there back in the database, refreshing materialized views, what to do when you've got 1,000 or more columns in an external flat file, how to deal with that, order by when it pertains to cursor sharing, detecting how big an identifier you're allowed to have in the database, whether it can be 30 bytes, 128, etc. The store in, we'll talk about that when it comes to partitioning, and some things with index status. All of these are driven by community questions, and so hopefully those people that ask those questions have taken the time to come onto office hours and discover them live, but if not, they'll get them in the YouTube recording. With that said, let's jump straight into it. Let me put my chat window somewhere where I can hopefully see it a bit better. And we'll do our best. So you'll see I do this kind of thing. It's hopefully to keep an eye on the chat window, keep an eye on the camera, keep an eye on the laptop we're doing the recording, and keep an eye on the desktop which is doing the demos. Busy times here. Partitioning with time zones. Here's the question that came in. I'm trying to interval partition a table with a timestamp with time zone column, and the database is returning an error. Why can't I partition this column? And the too long didn't read answer to this is it probably doesn't make a lot of sense to do so. Now, that's a bit of a flippant sort of dismissal of this question, and I don't mean to offend. Let's explore why. The first one is determinism. Time zones aren't these things that are fixed in stone. For example, if I had a query where I literally had a time zone column, a timestamp with time zone column, and I was looking for all the data that pertained to 1:30 a.m. in the morning. I'm not sure about the rest of the world, but in Australia, when we change time zones for summertime, etc., it's normally between 1 and 2 in the morning. So as I insert rows and they go in and then the clocks wind backwards, what do I do in terms of the partitioning scheme? Where does data go? One of the key elements of database performance when it comes to partition tables is partition pruning, being able to isolate partitions of interest when you come to running queries. If the partitioning key column was a time zone, well, yeah, it becomes a bit indeterminate as to where those partitions, where the data would sit in the right partitions as time goes backwards as we transit from summertime to wintertime and vice versa. So the first one is the issue of determinism. But one would imagine if you put enough work into the tech stack, you could possibly overcome that. The second one is this, is that time zones change over time. Now, let me explain what I mean by that. In Australia, in fact, in my state, we don't have daylight saving or summertime when summer comes along. And there were all sorts of reasons for this. I mean, there's a lot of FUD, fear and uncertainty about. People would say, oh, the curtains would fade more if we move the clocks forward. Or the cows would get confused and they wouldn't be able to go to the right time for milking. All these ridiculous arguments about why we shouldn't shift time zones in the summertime. I, for one, as you can probably tell, I'm biased. I would love to have summertime. I lived in Europe for a number of years, and I used to love those late evenings where the sun was still up, but we don't get it here in Perth. However, we did used to have it. Many years ago, we did have summertime, and at some point the government decided not to have it. So the definition of time zones around the world changes over time, and the Oracle database needs to take that into account. And in particular, if you select from your $V time zone file, you'll see what version your time zones are at. And on this database here, this is my local database, it's time zone number 32. That's not good because that means I've been lazy. The actual current time zone, I think time zone file is number 36 you can get. Now, I want to stress, just as a segue away from partitioning here, managing the time zones is your responsibility. It doesn't come as part and parcel with patching. In fact, this database here is running 19.11. It's about as up to date as you can get. I haven't yet downloaded and applied the just released July CPU patch. But 19.11, I've kept this database patched up to date, as I should do, as regularly as patches come out. You'll notice that the time zone was not updated with it. That is a separate responsibility you have as a DBA to keep your time zones up to date. But because you can see $time zone file, it tells you that time zone definitions change over time. What would you do with existing data if what used to be a time zone range is no longer a time zone range or a shift in time? That's another step in that indeterminateness or indeterminism about where data would be stored. They're the reasons we block it. So let's approach some of the considerations you might want to look at when it comes to actually using time zones and in conjunction with partitioned tables. There's a few things we can try, a few workarounds we can explore. Let me bring up a new share. So we're going to have a few attempts here at working our way through the problems that our questioner or our poster provided. So I've tried to create a table here called partition table, and I'm going to have a crack at partitioning on the my TZ column, which is a timestamp with time zone. And as the original poster presented, yeah, we're stuck. It says it's an unimplemented feature. And it literally is. You simply cannot do it in any way, shape, or form. What if I try a timestamp with a local time zone? And that you might think is perhaps a safer option because we're only using the time zone of the database as opposed to catering for any time zone information that would come in via an insert statement, etc. We still get the same problem. It says you're using an invalid data type. You can see we seem to be a bit closer. We've gone from unimplemented feature to invalid data type for partitioning, but we're still not allowed to do it. Interestingly, what if I do away with the interval? What if I say, well, let's actually explicitly define the ranges now? And hopefully, because at the moment I create this table, my time zone file is fixed. Therefore, maybe this is good enough to actually get this. So local time zone with explicit ranges. I get closer, but I'm still not allowed to do it. It says the data types aren't correct. And there's a subtle difference here between timestamp with local time zone and just a timestamp. If we look at the partition definitions there, the P1, P2, etc., I've just used a timestamp. I haven't actually provided time zone information, even though I'm assuming I'm using the local time zone of the database. So let's have one last attempt. And you can see this is about as close as we can get. If I have a local time zone, and I define them with the timestamp definition of the fully timestamp with time zone information. I've used +8 because that's Perth, my time here. So you can actually get close to having some sort of time zone information, but the key thing is it has to be the local time zone, and you're not going to be able to do it with interval time zones, I think because the partitions will be created dynamically. It's just a restriction on the Oracle database. Having done that, having managed to seemingly overcome this issue of having some time zone information with partitions, let's explore whether we actually get any genuine benefit out of this. So I'll insert some rows, 150,000 rows in there, gather some stats. And you can see I've actually got my partitions here and I've got some rows. I've managed to spread the data nicely over all the rows. Now I do a query where I say where my time zone greater than a starting and ending time zone. I seem to have partition elimination. And this is one of the things that I hesitate about using time zones in partition columns, even local time zones. It says I'm doing a partition range iterator, which is better than partition range all, which means the entire table. But one of the things I do see is I see these keys. Normally I would see explicit partition numbers. And that's one of the overheads because what we have to do inside the database is apply a number of sort of different functions, internal functions, to get all this data sorted out such that it's no longer time zone dependent. So be aware of the fact that if you do partition, even with local time zones, you don't get as good information from the execution plan. We can actually see if it actually is doing partition elimination. If I do a count here, you can see I've got 27,000 rows, which is the right amount of data. If I then go do a, select star from DBMS cursor, DBMS explain.display cursor, which shows me the details of the execution plan proper. The key thing you can see here is the starts column. If I scanned multiple partitions, this table access full would have a greater than 1 start number because I would start once for each partition. The fact that it says starts of 1 means I genuinely did get partition elimination or partition pruning. I only had to scan 1 partition. If I take that time zone column and then apply probably what I would say the more common predicates would be from users if they're doing ad hoc query, like for example, passing in a date, I get a similar kind of artifact. I am getting partition pruning, but I don't get to see what particular partition it is. I still have this key column information there. It's a bit like sort of a bind variable. If I do the fully qualified or fully defined timestamp with time zone information in my predicates, for example, up here, then finally I have some data type sort of parity, and I actually do see the values 1 through 6 instead of there. Now, that looks good, doesn't it? Looks like, yep, I'm now seeing the explicit partition numbers. But I didn't change the value of this predicate. This is still just 1 month out of my 6 months worth of table. And yet the database did partition range all. This is one of those really strange anomalies. This data type is timestamp with time zone or local time zone. This is a timestamp with time zone, and the database treats them as different. It's good enough to know what the partition ranges are, but it is always going to be all. That's a problem. So this is one of the reasons why things can get quite quirky when you're using timestamps as partition ranges. I'm generally not a big fan because there are so many sort of fraught little outlying edge cases depending on how the data is presented to the queries. If I run that gather plan statistics, you can see it actually did 6 starts. This is just to reinforce the other one where we saw starts of 1. You can see when I did 6 starts, it means I actually scanned 6 partitions. So putting the whole timestamp thing aside for a second, if you ever want to see how many partitions you actually scanned, look at the starts column when you do a display cursor result. It's a nice little useful tool to see how many things you did. What if I do something like my timestamp with 2 timestamp TZ as opposed to using that shorthand timestamp format I was using before? You get the same results. I'm doing partition range all, the same thing, all 6 partitions. So there are risks involved when you start heading down this timestamp territory. You have to be very, very precise and very, very correct, or you start getting some dramas. Rather than do that, I'm not a big fan of that kind of implementation. Rather than do that, if I was going to partition, I want to normalize my dates to something which is consistent worldwide, and that of course is UTC time or Greenwich Mean Time. So if you do have a time zone column, but let's try that again. If you do have a timestamp with time zone column like this one, what you can do is create a virtual column based on it, which simply gets the UTC value for it, just using sysextract UTC, and then you can partition on that virtual column. Now, that in itself has some side effects because if I then repopulate this table and do some queries, now when I do UTC, the virtual column, which is defined as UTC, I do get partition elimination. However, it's worth noting that I need to be careful here because UTC and your time zone will obviously be different. You have to be careful of the incoming data to make sure that it is also in UTC time zone. If I do UTC on a date, then I do get the nice partition elimination and I get told what those partitions are. However, if I go back to using my normal column, not the virtual one, which was not used as a partitioning key, the database at this stage is not smart enough to go, let's apply a transformation to the data, remap it to the UTC, which is the partitioning column, and do partition elimination. It's not good enough to do that. It simply scans all the partitions. So that's a downside. There are some virtual columns that do allow that, by the way, but not in this particular case. Back to the slides. So perhaps here's a mantra you can adopt. This is what I adhere to when I'm looking at partitioning, and it comes to time zones and using them in partitioned column keys. It is unlikely that time zones are the correct choice. And who knows, maybe that statement is where the term UTC comes from, which is the timestamp you do want to be using. UTC time zone is the way to go. Little pun, little play on words there, but hopefully you get the idea. If you can stick to UTC, much like our autonomous databases do across the board, you're probably going to have a lot less headaches. Number 2, let's talk about one of the fundamentals that we first learn when we first get into the Oracle database called %free. And as we all know, %free is how full a block is allowed to get before it's deemed full, and it defaults to 10. And I tweeted this recently as a bit of a teaser. I said, I love it when after using Oracle for 25 years, you find out something about one of the core fundamentals that you never knew. And how did it escape your attention? And that's what this particular topic was about. I thought I knew about %free really well. Here is the question that came in that prompted this investigation and prompted this wonderful piece of new learning. We've noticed that we have the default %free of 10 on all our tables. We've noticed that some of them are a lot fuller than %free 10. In fact, the blocks seem to be full. We never update. So how is this possible? Now, the first thing is, if you're on this call and this is your question, I need to apologize, because when this question came in, I replied via email saying, you're lying. This is such a common thing. We've gone beyond our %free, but we never update. I go, that's rubbish. The only way you do it is that's what %free defines. You must have updated. You're just not capturing all this kind of stuff anywhere. You might tell me that you're not updating, but I don't believe you. But as it turns out, I was wrong. I apologize. These people only ever insert. And yet they were getting blocks fuller than %free. Let's explore. So I want to stress first, %free is not broken. There's not some bug here in the database, but there are some interesting cases to examine. Let's go into a new share. Let's prove first that %free actually works. I'm very confident of this demo. I'll create a table called T. I'm putting 100 bytes into 100 rows. So that's about 10,000 bytes. So by definition, I know it's not going to fit into one block, an 8K block, because I'm putting in about 10K. Let's see what we get. If I use DBMS row ID to find out where the blocks are, you can see I got 68 rows into the first block, and then I was deemed full, and I got 32 rows into the next block. Let's do some basic mathematics. 68 rows. Each row is about 100 bytes long. I need a length byte, which is a couple of bytes, and I need an end of column byte or end of row byte, which is 1 byte. So about 103 bytes times 63. 8K block, 8192 bytes. We lose around about 200. I'm being a bit sort of loose here. We lose a couple of 100 bytes in terms of overhead in the block, things like the block header, the intra-transaction list, the SDN information, the checksum, the tail, etc. We lose a bit of data, about 200 bytes. And you can see that block with 68 rows is around about 90% full based on this loose sort of back of the hand calculation. It's 87%. We're close enough to 90% full. We got to 68 rows. The database said that block's full, or it's 90% full because %free is 10. Well, let's move on to the next block. So that's a proof that %free works. If I gather, this is the customers table. I'm gathering stats, so the stats are up to date. I look at my table and it says they had %free of 10, 2,719 blocks. This is the customer table. This was their proof that they were having some dramas. If %free is 10, they only ever insert, and they have 2,719 blocks. When they do alter table move, I should get the same result. Every block is 90% full. I move it to a block that's 90% full. Regather stats. This is what they got. The table grew from 2,719 blocks to 2,998 blocks. %free is still 10, and they insist and could prove to me that they had never done an update. So what's going on? It turns out, and this is a simplified version, they had hit a very, very particular outlier case when it comes to %free. And this is a deliberate part of the Oracle implementation. I've simplified it down to just a 2-column table. Theirs had a lot more columns. I've got my table called customer. It's got 2 columns, X and Y, each of varchar 2 4000. I'm going to insert the following row, and I've picked these numbers particularly. Each one is 3,975 bytes long. So I've inserted one row into the table, 2 columns, each of 3,975 bytes. If I actually go and look at what the block number is for that row we've inserted in the table. It says it's in block 37755, file number 64. Here's my default trace file for this session. And then I'm going to do an alter system dump data file. So we're going to dig into some internals here, but this is really just to prove to you that that row is stored in a single block. So I need to do a new share because I've fired up Notepad with that trace file. And here's the block dump for that particular block. Now, we're not going to go into all this. In fact, if you come to the Polis Oracle user group in September, I'm doing a talk on block internals, but we won't cover that today. The key thing here is here's our block dump. And you can see in this block, we have one row, and that row has 2 columns. So the column count is 2. In fact, you can see this I did RPAD 3975 of the letter X, which is ASCII code 78 in hex. So there's the first column. If I keep scrolling, eventually we'll get to the second column, and down we go, etc. So there's the entire block. That proves to you that both those columns in that row are stored in just this one block. So I've just proven with, by looking right into the nitty gritty of the Oracle database, that those 2 columns in that one row are on a single block. Dogs come to join me. But let's do a bit of back of the hand mathematics again. I've got 3,975 bytes in the first column, same in the second column, length byte, end of row indicator, times 100 to get a percentage, 8K minus 192 bytes. That block is 99.4% full. Now you can see why I chose the 3975. It gets me right at the threshold there. But there's an example of a single insert. This table's never been updated, never been touched. One insert, the block is 99% full. If I do the create change row tables, most people are familiar with analyzed list change rows. If I list change rows, there are no change rows. So that's another proof that row is not spanned across multiple blocks. It all sits in one block. So there you have a proof that under particular circumstances, a block can be more than the fullness as indicated by %free. In this case, the block is literally 100% full. And it's part of the implementation of the Oracle database is that the first insert into a block, we almost ignore %free because it would make no sense to immediately move that row somewhere else and leave that block empty. So we don't do it because if we moved it elsewhere, we'd simply end up with the same problem. That has to go to another block and we have the same issue. So we would immediately end up with a row which would be chained across multiple blocks, even though it didn't need to be. So that's why we do it on that first insert into a block. So here we have this chained row tables. There's no chained rows at the moment. Here's where this customer was having some dramas. As part of a normal reorganization process, they would do alter table custom move, list chained rows. Now I do have a chained rows. When we come to remove that block or to reorg that block, we're not doing a row operation at a time. We're doing a block operation at a time. And the database looks at the block and says it has crossed the %free threshold. Therefore, I need to now respect %free at a block level. And therefore the row gets split into 2. And that's why they went from a smaller table to a larger table just by doing alter table move, because in their particular case, they had lots of columns in their table, but that full row would actually consume almost an entire block. Back to the slides. Q&A here. Someone say, where would I go to find the trace file on an autonomous transaction processing system? Nowhere. Tracing is not yet permitted on Autonomous Database. However, it is coming. I've seen a roadmap for Autonomous, and SQL trace facilities and trace file facilities are coming in an upcoming iteration of the Autonomous Database. So stay tuned. But yeah, as I said, safe harbor, I never know whether these things actually come, but I've seen a roadmap of planned activities. Hopefully it'll come, but there's obviously a difference between planned and reality, but there's an aim there. The way I like to think about this is we can think of %free as being a decision of the database decides when will the next row exceed the %free threshold. So I'll let a block get up to 89% free if I'm inserting small rows. And then if I think, if the next row is going to cross into the 90% category, I'll put it somewhere else. In this case, we insert that first row, and then it's the next row that we would say, yes, it's not going to fit. It's the block has exceeded %free, therefore we move it. So that's mentally the picture I put in my mind, that we're always thinking about, should the next row be allowed in? And that's why that first row is going to go in, even if it takes the block over the normal default %free. As I said, something brand new I learned. I think this explains, you obviously need to be careful with niche cases. This is the only time I managed to concoct this example, and this customer was just, you could say, desperately unlucky that their rows happened to be almost coinciding with the size of a block. You could perhaps make an argument they would maybe move to a 16K block size and they wouldn't see this, but I think that's probably a little bit of overkill. It's just, once you know about it, there might be special niche boundary cases where you just need to be a little bit careful about when you do things like alter table move, etc. Helmets also said, alter table move compress resets %free to 0. Yes, that's one thing that's worthwhile. Any kind of compression, no matter what you do with %free, will always do %free 0. Just be aware of that. It's one of the, because if you're compressing data, we're assuming that you're doing it to get as much space and compactness value as possible. So almost all the forms of compression will always immediately set %free to 0. Thanks for pointing that out, Hemant. Quick drink. How do they get to 937? Go on. I talk too much. I'm glad no one said that in the chat. Materialized views. Question that came in. We have a data warehouse, obvious choice from materialized views, and a number of the materialized views were taking too long to refresh, so we dropped them. I like this approach. I like the idea of that's running slow. Let's get rid of it. The fastest way you can run something is not to run it at all. And yet our refresh procedure still runs for a long time. What's going on? And that bamboozled me, because a little bit of back and forth with this customer, and they said, yeah, we've dropped all of them. All the materialized views in our data warehouse schema are gone, and yet the refresh procedure we're running is taking a long time. And that had me scratching my head. And ultimately, this turned into an example of understanding the built-ins available to you. This is a simple misinterpretation. So the fact that one customer had this misinterpretation, I thought it was important that we should share it with the community so no one else gets hit by this as well. Oh, I should have better formatting there. Would have been nicer, wouldn't it? So I've got one materialized view in my schema at the moment called MV, and it was last refreshed at 21:38. 38. As you can probably tell, I just created it there. I'm going to refresh it now. So, I'm going to refresh all my M views and just chug away. And this is the procedure the customer was using. It's nice and simple, just one call to an API. Takes a little while because that materialized view might be obviously a bit complicated, and it's done. And this is the same customer issue we have here. That took way longer than I would have liked. I don't like that. And if I go look at the last time all my materialized views have been refreshed, we start to get an inkling of what's going on. I did refresh all M views. Here's my M view in my own schema here, which we refreshed at 28:38:56 just a few seconds ago. But I've got a materialized view in the Ask Tom schema. I've got a couple of them. I've got a materialized view in the SamGam schema from one of my talks last year. And notice they were all refreshed as well. And that's a key thing to remember. DBMS MView refresh all M views is database wide. In fact, easy way to prove that. Let me drop my materialized view. So there's no materialized view in my schema anymore, and I run it, and guess what? It's going to run for 15 seconds again, or however long it took last time, even though there are no materialized views in my own schema. And this is where the customer was getting simply caught out. They were using this documented view, and nothing while it was going on, they had materialized views for other applications in other schemas. The easiest way of seeing that this is an issue is if I connect to a much lower privileged user. I was logged on as a DBA before, like Scott Tiger. I try run refresh all M views. I get insufficient privileges because Scott doesn't have the privileges to refresh materialized views in other schemas, obviously, and that's the default thing. So be aware of that. Refresh all M views is one of those rare utilities that doesn't look just in your own schema. Almost everything we do in terms of APIs normally sits just in our own schema. Refresh all M views doesn't. It's looking database wide. So what should we be using? Well, let's explore a bit further. I've reconnected as a DBA user. That's my local user here. Here are my other schema materialized views. They've all been refreshed at 2140, except for this game one. How about if I run this, dbms mview refresh all? Now that came back instantaneously. So presumably, if we have a look, it hasn't refreshed any of the schemas that took at least 15 seconds. Let's create a new materialized view now in my own schema. So I've called this materialized view in my schema. So now I've got one in my own schema. So maybe that's what refresh all touches. It's also instantaneous, but maybe it still refreshed it, but it didn't. We can see here that the refresh time hasn't been changed. So what does refresh all do? If it doesn't refresh things not in your schema, and it doesn't refresh things in your schema, what does refresh all do? It does nothing. Well, it does something. It's not in the documentation. It used to be, but you won't find refresh all in the documentation anymore. Refresh all is actually a hangover of the legacy of materialized views. Who remembers when materialized views were called snapshots? And back in the day, back in the Oracle 7 days, you would create these things called snapshots as part of advanced replication. And as part of the actual DDL, you would say, I'm going to create my snapshot, but you would actually put the refresh interval inside the DDL definition. I want to actually refresh it every 7 days, for example. What would happen is the database would create something in dbms job for you to actually take care of that. dbms refresh all, dbms mview refresh all would actually run all the jobs that were defined to refresh snapshots. So we don't do that anymore. So refresh all does nothing unless you have these older style DDL commands that have actually created jobs to run snapshot refreshes for you. So refresh all you shouldn't be using, and which is why we took it out of the documentation. This is generally probably what you want to do. It's a little bit of code. It's sad that we don't have a schema level API, and I'll put an enhancement request, but we know what's going to happen there. And yeah, just write yourself a little loop, select username for your own MViews, and then just dbms mview refresh. That is the equivalent of a schema level refresh all my MViews. And you can see now that in my schema has now been freshly updated. So just a little bit of a sort of misnomer there and misinterpretation of how these things work. I will dwell just a touch on materialized views is the fact that this customer was happy to drop materialized views. I think is actually a good thing in general. Materialized views I often find, don't get me wrong, they have their place, but are often a legacy of how we used to approach, especially data warehouses in the concept of load the raw data and then spend a lot of time building lots and lots of different summary informations and storing them as well. But a lot of that stuff, especially if your database data warehouse is read-only, and that's the most common example, read-only for a period of time, that's why we create these materialized views, is look at things like result caching. Result caching is like a just-in-time materialized view. And in that way, you can actually cache the results as opposed to caching the summary data. So rather than running a materialized view, run the same query, but use a result cache. And therefore people get the benefits, even faster results, and you're getting effectively the same kind of benefits. We have all these technologies now to make querying large amounts of data in an ad hoc fashion very, very efficient. We have full database cache, large table caching, automatic large big table caching and warehousing, and of course in memory. Even if you're not licensed for in-memory, doing something like using the free 16 gigabytes worth of in-memory, for example, just the most recent partitions in your data warehouse, is often all that's needed and gives so much more flexibility than telling your customers, oh yes, that's the summary table we've created for a materialized view, that's the query you have to run, that's it. So always look for examples where you might be able to do away with materialized views simply as a reflection of how modern the hardware has become and how modern the technical features have become when it comes to data warehousing and analytics. Okay. Yeah, we've got plenty of time. CSV with 1,000 plus columns. Really, this is about external tables with 1,000 and more columns. Here's the question that came in. I know that an Oracle table can only have 1,000 columns. We have a CSV file that has more than 1,000 columns. Is it possible to query this as an external table? I will do my best not to say, where do you get 1,000 plus columns in an Excel spreadsheet? But it obviously exists out there. Too long didn't read? No, you can't. You cannot get more than 1,000 columns in an Oracle table, no matter what kind of table that is. But when it comes to external tables, we can maybe do a little bit of trickery, a little bit of magic to get someone close to what they want to achieve. So I put demo here in quotes because when it comes to creating tables with 1,000 columns or more, having that in SQL Plus is just ridiculously long script. So I thought I'd do some screenshots first, and then now once we're familiar with what I'm going to talk about, then I'll do the real demo where things will scroll past very, very fast. So here's our Excel spreadsheet, and I've cut it down the middle because it's got, in this case, 1,200 columns. And to keep it nice and simple, you can see column 1 has the value of 1, column B or column 2 has the value of 2. All the way out, I did 1,200 columns here. And you see, what's it? Column ATD has the value 1,200. So it's a CSV file, just one row to keep it simple, 1,200 columns in the Excel spreadsheet, which then became a 1,200 column CSV file. If I try do this, a normal external table, which is create my external table, here's my 1,200 columns that I want to get as a result. Here's my 1,200 columns defined as the mapping inside the external table definition, much like a SQL loader control file. As you would expect, it says, I'm sorry, you're asking for 1,200 columns and you don't get them. But you don't have to have those two parts of the definition in alignment, just like you would in a SQL loader control file. So I can do something like this. Create table T. I want just columns C1 and C2. But in the lower part of the definition, I can still have those 1,200 data elements that are coming from the CSV file. So only 2 columns in orange and 1,200 columns coming as the mapping information coming from the CSV file in green. That's totally legitimate. So now I can query columns C1 and C2. At which point you think, well, that doesn't really get me close to where I want to be. But if I can do that, I could look at something like this. Create table T first 1,000 columns, which has the values C1 to C1000, and then the full 1,200 column mapping in the external table definition. Then a second table, which is the remaining columns, starting at column C1001 up to C1200, and once again, the full 1,200 columns in the data mapping. They're both valid. And then I can do a query which has some sort of sensible join condition. So I need some definition of what a primary key would be for those rows. It might just be the first column, or I could maybe use row num, etc. But I can actually get more than 1,000 columns in a result of a query. I just can't have 1,000 columns in a table. So in this case, I could actually join those two tables, select T1 star, T2 star, and get a 1,200 column result, even though I can't have a 1,200 column table. So that's the theory that you should be able to potentially work around this. Let's now look at the real demo where we can fly through some of these scripts and see what the implications are. So as I said, things are going to scroll through here a lot. So here's create table T1. It's got the first 11 columns, and then there's the whole 1,000 columns. So there's the first 1,000 columns in my T1 table. Here's the start of my 1,200 column definition. There's C1, C2 up to C5, all the way up to C1200. And that creates fine. That's a table T1 that gives me the first 1,000 columns. Create table T2. It starts at C1001. And I'm only just picking the last five columns here just because you understand that I would go to 1,200 columns here. The columns 1,000 to 1,200. And the same full 1,200 definitions in there. And so I have T1, the first 1,000 columns, T2, the next 200 columns. I just grabbed a few. Let's see if I can actually do this join. I've left out any join condition here because we saw from the Excel spreadsheet, there's only one row in this thing. Normally you would have a join condition to make sure all the rows. Normally you would have a join condition to make sure the rows obviously don't do a Cartesian join, but this is a nice simple one row example. If we run it, it works. You can actually see the data coming out. It starts at column number 1 and goes all the way up to column 1005 in this particular case, because I only put 5 columns in the second table, but there's more than 1,000 columns there. There you go. You can actually query a external table with more than 1,000 columns of data and get the results out. But there are some things to be aware of here. What happens if I try to think, yep, I'm happy with that query, that's great, let's try put it in a view. You can't do it. A view can't have 1,000 columns just like a table. So even though that query runs fine, I can't put it in a view. Because I can't put it in a view, you might be thinking that's going to introduce even more implications, and it does. What if I just do a with statement? I just want to, create the view like as effectively a temporary thing. So I just put it in a with statement. I'm not creating a database dictionary objects now. I'm just doing a with statement. Same problem. Even like that, you cannot refer to this thing with more than 1,000 columns. In fact, I can't even just use like that. I can't even nest this as a subquery or an inline view. Same problem. So yes, you can get around this problem, but there are some implications and some limitations, obviously. What I say with this thing is yes, we have a workaround for you. You get this, this join between two tables with lots and lots of columns, but you really are heading into what I call pioneer territory. You never want to be a pioneer when it comes to technology, because the pioneers are generally the people that encountered the enemies, got slaughtered, they became a lesson to others. And it's one of those things where I can be pretty confident that inside the Oracle testing area, there isn't a huge number of test cases that we are writing to check out what happens when you have more than 1,000 columns in a result set coming from two external tables which are joined together. It's a very niche requirement. So I would be looking at revisiting why you have an S and CSV file with that many columns in it. Maybe it's just a case of reviewing the data. It seems to be very strange to have over 1,000 data elements for a particular attribute. It just seems very odd to me. So be aware of that. Once you start heading to this kind of territory, you're sort of a bit on your own. It's unlikely that other people have been here before you, and unlikely that the bugs have been discovered because it's such a niche case. But I will say, I tested these up to 10,000 columns in the external table definition. I got bored after that. So you can create a table with up to 1,000 columns where it has to sift through over or up to 10,000 elements defined in the data mapping. And that worked fine. So be aware it can be done. And also, if you're on Autonomous, we have someone there mentioned Autonomous before, we load external tables using the DBMS Cloud package. That's all supported there as well. So using DBMS Cloud, I did a demo here, same test. My field list had all 1,500 columns, C1 up to C1500, and my column list just had the columns of interest. So even though we're using a package DBMS Cloud create external table, the API supports that same process of having less columns in the table and more columns in the external table definition. So that works fine as well. Someone says, why is the number of columns in a table limited at all? I would imagine it's because of the way we implement columns in a block, in the sense that we have for historical reasons, for many, many years, so since the dawn of time, Oracle had originally a 1-byte field which indicated some column mapping. That's why you had 255 columns in a table, because we had a simply 1-byte thing that referenced that information in the block. That's why if you have more than 255 columns in a table, we actually span rows. We don't create a single row with 300 columns in it. We create a row with the first 255, then a column with a row with the next 255, and we link them together. The underlying database architecture was built on 255 columns, and therefore when we extended this to go to 1,000 columns, 1,000 I always thought was an interesting choice. I would have thought 1,024 would be the logical equivalent, but I would imagine it's because we have limits on how far we want to start tracking rows. If you query the 1,000th column of a table, then you're going to be jumping through actually 4 rows, 4 hoops, because we have to follow these chains. I would imagine that's probably why we chose an upper limit, because otherwise, if you have an arbitrary number of links, then it becomes a little bit more complicated in terms of managing the rows and managing the blocks. So that would be my suspicion as to why just sitting on top of an existing legacy of the fact that originally we had 255, and therefore that linkage issue is there. Second question: if we get rid of materialized views on the things that in cache that can be referred by a select and a procedure. Yes, so effectively, if the cache not there is a mechanism to load on first reference. Yes, if you didn't have materialized views, let's say you were going to use result caching. A materialized view might be select, something, an aggregate by year of all your sales. Your original materialized view would be create materialized view as select statement. My proposal is, rather than doing that, you could simply do, at the end of your database load, simply do select result cache, that same query. Now, you could run that yourself, and therefore no one pays that price when they come on later and do it. Or you could actually, let the first person that does it pay that price. The cool thing with result caching is you don't have to, there's no program you have to run to prime a cache. The first person that needs the value put in the cache will do that effort. That could be your first customer, or you could do it as part of your database, your data warehouse load, such that the customers don't have to do it. If that is, for example, that query is then defined in a view which does result caching, then you simply query that view, and then you let people query that view in any way, shape, or form, and the result caching is automatic. And if someone goes and changes that data due to maintenance, whatever, then the cache is automatically expired, and the next person that runs that query then pays that price to repopulate the cache. So result caching is very cool in that sense. Obviously, if your data warehouse is being changed regularly, then maybe result caching isn't the way to go, because every time you change that data, the result cache becomes marked stale, and therefore people pay that price of repopulating the data. But generally in those cases, if you're regularly changing in near real time your data warehouse, then you wouldn't use complete refresh materialized views anyway. You'd be using materialized view logs, etc., to do incremental refreshes. So hopefully that answers that question for you. Well, that Q&A, of course, is made a giant mess of the timing. No, I'm not blaming you. I'm blaming me for being slow. So we didn't get, what did we get, halfway through? That's just tragic. Not to worry. So we are out of time, but I'm glad that I've actually got 1 more minute left, because as always, thank you very much for attending office hours. I should always thank the audience that are here first. Thank you very much for your time. Hopefully you found it interesting. I'll obviously cover these other topics in the next office hours session when it comes along. But I will finish off, let me close the share. I will finish off with one thing, and if you'll permit me a small indiscretion, I'm going to open a beer. And people that know me know that beer is probably not my normal beverage. I'm a gin and tonic person, but one of the things that Peter, our good friend Peter, would always do at conferences is he was always desperate to go to the nearest pub, grab himself a local beer, and he was a Belgian, so he obviously knew a lot about beer. He was a fine beer drinker. But we'd sit down, have some bites to eat, have a beer, and we just talk tech, talk about the world. So this one's really for Peter, just a toast to his memory, to his contribution. If you've ever used DataGuard, then you have him to thank. He's a big part of that, was a big part of that DataGuard team. We'll miss him, and he was a fantastic element of the Oracle community. So cheers to Peter. Cheers to you for office hours, and we'll see you all again next month. Thanks, everybody.